Hi everyone. If f of x equals 4x to the fifth plus x, then f is an odd function. Let's go to Desmos. How do you graph y equals x? The identity function is that slanted line. How do you graph y equals x to the fifth? Oops. That's that rising snake. Y equals x is kind of a dead straight snake. Y equals x to the fifth is a tall, proud snake in blue. When you add them, y equals x to the fifth plus x. Right? Notice the odd property is retained. The red graph, the blue graph, the red graph, the blue graph, and the green graph are all symmetric about what? They're all symmetric about the origin. They all represent odd functions. And by the way, if 0 is in the domain of an odd function, and since these are polynomial functions, 0 is in the domain, all real numbers are in the domain, then the point 0, 0, the origin, must lie on the graph. If 0 is in the domain of an odd function, then the origin must lie on the graph. Because when you rotate 180 degrees about the origin rotates onto itself. Now, here I asked about y equals 4x to the fifth plus x. Y equals 4x to the fifth plus x in black. Still, that retains the odd property, and it again goes with the origin. This is the guy I ultimately cared about. But again, a linear combination of odd functions is odd. 4x to the fifth plus x to the first, that represents an odd function. Notice I said 4x to the fifth plus x to the first. We can think of x as x to the first. And if you look at this polynomial written in descending powers of x, the exponents on x, the 5 and the 1, these are both odd integers. And when we look at the exponents, we do think in terms of odd integers versus even integers. The 5 and the 1 are both odd integers. Therefore, f is an odd polynomial function. And we have symmetry about the origin on the graphs. Now, question. What happens if we add or subtract a 1 or a 2? Well, then we get something like what we see here. In example 5, let g of t equal t cubed plus t plus 1. Is g even, odd, or neither? Well, let's check it out. When you look at y equals t cubed plus t, y equals t cubed, our familiar snake, plus t. We retain the odd property, symmetry about the origin. All right, so this here represents an odd function. But what about that plus 1? Y equals t cubed plus t plus 1. What happens? The graph goes up 1 unit, but the blue graph, is that symmetric about the origin? The answer is no. It is symmetric about this y-intercept at 0, 1, but that's not the origin. Remember, if 0 is in the domain of an odd function, the graph must go through the origin. Now, 0 is in the domain for this blue graph, but 0, 1 is the y-intercept. If you try to rotate it 180 degrees around the origin, you get 0, -1. That point cannot also be on the graph because otherwise we'd fail the VLT. So again, if 0 is in the domain of an odd function, the origin must be on the graph. This is why if you add 1, 2, 3, subtract 1, 2, pi for that matter, if you add or subtract any non-zero constant, I guess I should go plus 1, plus 2, plus 3, minus 1, minus 2, minus pi. These do not represent odd functions. So the odd property is more delicate than the even property. Remember that the even property is retained if you add or subtract a real number, 1, 2, pi, whatever. But the odd property is destroyed if you try to add a 1, a 2, a pi, or subtract a pi. You destroy the odd property. It's more delicate. because if you try to add a 1, for example, you're moving the graph away from the origin, and that's dangerous for an odd function. Well, what about the exponents? Here we have t to the third. Okay, that's odd. T to the first. Okay, 1 is an odd integer as well. But wait a minute. 1 is 1t to the what? It's 1t to the 0. And 0 is an even integer. T cubed represents an odd function. T to the first represents an odd function. But 1 is a non-zero constant function. It is even and not odd. I don't care that 1's an odd integer. 1, 2, 3, pi, negative pi, they all represent even functions, not odd functions. The 0 function is both even and odd. But here's the problem. The exponents are a mix of even and odd integers. Or I should say odd and even integers, which means that we have the neither case. The function is neither even nor odd, because look at this graph here. Y equals t cubed plus t plus 1. Look at this blue graph here. It is not symmetric about the origin, so the function is not odd, and it's not symmetric about the y-axis, so the function is not even. It is neither even nor odd. If you try to add 2, 3, subtract pi, none of these are either even or odd. They're neither. We have the neither case. Next up, we'll talk about the proofs. How can we prove that a function is even, odd, or neither?